Welcome back to Tracing the Sky. So, in this episode, we're going to start a series I'm really excited about. We're going to be looking at Ptolemy over the next few episodes and breaking down his contributions to astronomy step by step. Now, maybe you've never heard of Ptolemy, but he is one of the most significant figures in astronomy, and I hope by the end of this series you'll understand why. In this first episode, I'll give you a bit of background on Ptolemy and set the stage for his contributions. We'll revisit some of the important observations that we need and problems that we're trying to solve in astronomy so that we can start looking at his contributions in more detail. So let's jump in together. Ptolemy lived around 100 to 170 AD. So that puts him about 200 years after Hipparchus, who we looked at last time. He lived and worked in Alexandria, which at the time was part of the Roman Empire. Alexandria was a hub of knowledge. Ptolemy had access to works from Greeks, Babylonians, and Egyptians, and he was able to study them in detail. Now, Ptolemy's greatest contribution by far is the Almagest. You can think of the Almagest as almost like a textbook, part history of astronomy, part presentation of his model. It gives us a ton of information about other historical astronomers, Greek, Babylonian, and Egyptians, and also presents his model of the solar system. Now, much of the series on Ptolemy is going to be focused on his model. Now, his model was so accurate at predicting the positions of the planets and other celestial bodies that it would be over 1,000 years before someone was able to make a model that was more accurate. In fact, it would take a while before they were even able to create measurement tools that could prove that his model wasn't accurate. Before I show you Ptolemy's model, I want to go back and revisit some of the fundamental observations we made earlier in the series. That'll really help us appreciate the kind of problems that Ptolemy's trying to solve. In particular, I want to focus on planetary motion, right? Those wandering stars. I want us to revisit how we discover planets and what makes their motion so peculiar. With that under our belts, we'll really be able to appreciate what Ptolemy is trying to do. And in the next few videos, we'll really start to look at what modeling even is and how important Ptolemy's contribution is. So let's hop into rediscovering the planets and how they move. Well, let's dive in and remind ourselves about some fundamental details that we haven't covered in a little while. First of all, you can see that I've got Taurus on the screen here. Now, if you remember, one characteristic of the stars is they all move together. Right? If you observe the stars and how they're moving over time, especially over the course of a single night, they're moving as a single unit. And because the distance between the stars never changes, there are groups of stars that stand out that you can connect to create shapes. And these are called constellations. And many different cultures over the history have discovered constellations, created constellations, and written myths about these constellations. So even though these were constellations, these grouping of stars that they were observing hundreds of years ago, even thousands of years ago, we still see them today because the motion of the stars has remained constant. They all move together and the distances between them don't appear to change. So we can see that in action. If I move us forward a few minutes at a time, you can see that all of the stars appear to be moving from east to west or from left to right on my screen, right? None of the stars in Taurus are moving further apart from one another or getting closer together. You can see that shape of Taurus. And if you expand your field of view, you can see that all of the stars appear to be moving in that same way. Now, if you recall from earlier videos, things get interesting when you look at the stars over the course of multiple days, right? When we look at the stars, they're going from east to west, and they appear to be circling back to where they started. But if I jump forward one day, 24 hours, we see that the stars, Taurus in particular, you can see, has shifted a little bit further west. I'll do that again. Notice Taurus where it is, and it's gone a little bit further to the right on my screen, which is west. And so the stars appear to be going around the Earth once per day, but shifting a little bit further west, right? It's almost like they're going a little bit faster than one rotation around the Earth per day. We saw that the sun and the moon appear to be lagging behind the stars, right? They're not going as fast around the Earth as the stars each day, so they lag behind. But this sphere of stars appears to be going once around the Earth and a little bit. And so what gets really interesting is when you start to observe the stars closely. Well, now is a great opportunity for you to try this yourself. I've linked to the celestial journey that helps you discover the planetary motion. I'll give you a quick little tour of what to look for, and then I'd recommend pausing the video and giving this a try. So, what you're going to do when you open the celestial journey is you'll see exactly what's on screen. You'll see Taurus, right? And your challenge is to find the thing that isn't moving like the stars. What if I told you that among all of these stars, there is a planet, and it's somewhere around Taurus? Now, to the naked eye, it looks pretty similar to the stars, almost identical. It's very hard to tell them apart. Now, how would you find the planet? Well, one thing to do is to try and figure out if anything isn't moving like the stars. Now, you know the stars move in a particular way. If you move forward using these arrows in the bottom left corner, one day at a time, you know that all of the stars will move together. They'll move together as one. And so you can move forward one day at a time and try and see if any of these stars appear to be changing their distance from any of the stars in Taurus. Now, you could compare any two stars, but using a constellation like Taurus is a great anchor. You know all of those constellation stars are moving together. So you want to make sure you're not accidentally choosing two planets, right? So in order to do that, you can compare any other dot of light to one of the stars in Taurus. And what you can do is you can use this slider to go back in time. You can jump from, let's say, day 5 to day 1 and compare what you see. This is pretty similar to what the ancient astronomers would do. Now, instead of being able to look at pictures like you are, a visual representation, they would have to compare tables of coordinates. So your job's going to be a little bit easier, but it's going to be walking in their shoes pretty closely. Now, one other tool you can use is this ruler. You'll see in the bottom left-hand corner you have this ruler. And so what you can do is you can click on a star and then click on a star in Taurus, and you'll be able to see the distance between them. Okay, so you'll be able to measure the distance between two objects, right? What you think is a star and an object in Taurus. At least that's what I would recommend. Now, if what you clicked on was a star, then the distance between it and one of the stars in Taurus would never change, right? So if I jump forward a day, you can see that it's still 11:38:59. I'll jump forward another day, it's still 11:38:59. So the distance between them never changes. But if the thing isn't moving like a star, then maybe its position does change. Maybe its position relative to the stars changes over time. Maybe it gets further away or closer together. So you can make this measurement on a particular day and then see if it changes on any day. And test it. Go forward many days into the future and see if the distance ever gets further apart or closer together. So pause the video here and try this out and see if you can find the object that isn't moving like the stars. And once you think you've discovered it, come back and we'll see if you found the same thing I did. Well, I wonder if you got the same thing as me. If I compared each day really closely, there was one object that appeared to move. And so what I did was I measured the distance between this particular object here and a star in Taurus, and between the star in Taurus and a different object. Now, if both of these are stars, then the distance between them, right, would not change. It would be the same every single day. So let's see what happens. If I jump forward, is this still 10:8:56? Is this still 4:26? Well, if I jump forward, this one is still 4:26, but this one's no longer 10. It's moved. It's gotten closer to the star. Let's see if that keeps happening. If I jump forward again, now it's 9:44. This is still 4:26 though. So this one appears to be moving. What if I compare day 10 to day 1? If I jump forward, now you can really see it. On day 1, the star was between the legs of Taurus, but on day 10, this apparent star is outside of the legs of Taurus. So this can't be a star at all. By definition, all of the stars have to move together. And then yet this thing appears to be wandering through the stars. It's moving through the stars. So this object is not a star. And if you click on the object and you click the check mark to see what it is this the right thing? Is this the thing that isn't moving? You'll learn that you've discovered a planet. You've discovered Mars. This point of light is actually Mars, and it is Mars wandering through the stars. And so you've discovered your first planet. So this is a great place to pause this episode. I'll link to a second journey that you can complete on your own before watching the next episode. Now that we've picked out Mars from among the stars, the next thing to do would be to track Mars over time. How is Mars moving? And is it moving in a way that's similar or different to, let's say, the moon and the sun? In other videos, we've already looked at, like I said earlier, how the moon and sun are lagging behind the stars. And they're tracing a path through the stars. But their motion seems to be pretty straightforward. You'll find something really interesting if you take the time to track a planet over multiple days. So in this journey, Mars is already going to be selected for you. And you can click this button or press the C key on your keyboard to drop a celestial marker. This is going to drop a point among the stars of where Mars was on a particular day. What I then recommend is moving forward at least 5 days. So let's say we move forward to day 5. And what I would recommend doing is every 5 days, dropping another one of these celestial markers. You can see the previous marker that I dropped on a particular date, and you can see that we moved 5 days forward and the date of this new marker. So you can continue to do this every 5 days and drop a new celestial marker. And you can see how the planet is moving through the celestial sphere, through those stars. So if you do this, I wonder what you'll find. So take the time to do this exercise and come back and watch the next episode once you've completed it. And I'll show you Mars's complete path through the stars over a period of time. And we'll see what's particularly interesting and challenging about its motion. And that will set us up to look at Ptolemy and his model of the solar system. I'll see you next time.